1.8 Equilateral and isosceles triangles. Parts of an isosceles triangle. The two congruent sides are called legs, shown in the diagram in the color blue. The angle where the legs intersect is called the vertex. In the diagram, this is angle B. The side opposite the vertex is called the base, colored green in the diagram. The angles along the base are called base angles. Isosceles triangle theorem. If two sides of a triangle are congruent, then the angles opposite those sides are congruent. Angle A is congruent to angle C. Notice that these are also our base angles. If two angles of a triangle are congruent, then the sides opposite those angles are congruent. AB is congruent to BC. Notice these are the legs of our isosceles triangle. Let's do some examples. Angle L and angle J are the base angles and are congruent. The measure of angle J is equal to 68 degrees. I can use triangle sum theorem to find the measure of angle K. 180 minus 2 times 68 equals 44. The measure of angle K is 44 degrees. Example 2. Let's label the unknown angles with a variable. Use the triangle sum theorem. 2x plus 106 equals 180. Subtract 106 from both sides. 2x equals 74. Divide by 2. X equals 37 degrees. The base angles are equal to 37 degrees. I'm going to label the unknown angle with an x. Use the triangle sum theorem. 2 times 77 plus x equals 180. 2 times 77 is 154, plus x equals 180. Subtract 154 from both sides. X equals 26. Measure of angle y is 26. Yx is one leg of this isosceles triangle. Yz is the other leg. Yz equals 12 centimeters. Equilateral triangles. A triangle is equilateral if and only if it's equiangular. If the measure of angle A is equal to the measure of angle B is equal to the measure of angle C, then AB equals BC equals AC. If AB equals BC equals AC, then the measure of angle A is equal to the measure of angle B is equal to the measure of angle C. Number 11. In an equiangular triangle, the measure of every angle is 60 degrees. The measure of angle C is 60 degrees. Because this is an equiangular triangle, it is also equilateral. So the measures of the remaining sides are 9 feet. Number 12. Because of the given congruency marks, we know this triangle is equilateral. This means it's also equiangular. So the measure of each angle is 60 degrees. Now for a more complex example. If angle PQR is an equilateral triangle, solve for x and y. Let's begin by solving for x. We know that this is an equilateral triangle, which means it is also an equiangular triangle. 7x minus 3 equals 60, and solve. Add 3 to both sides. 7x equals 63. Divide by 7. X equals 9. To solve for y, we can use any two of the three side expressions. Because this is an equilateral triangle, whichever two expressions you choose to use, you will set them equal to each other. 11y minus 23 equals 9y plus 1. Subtract 9y from both sides. 2y minus 23 equals 1. Add 23 to both sides. 2y equals 24. Divide by 2, and y equals 12. This concludes the notes for 1.8 equilateral and isosceles triangles.